Thank you very much. And so, yes, I was presented. I'm going to talk about LabsLand, but actually I was very interested in the last presentation because even if I don't speak Polish, I could understand the last part. And I wanted to actually to start from where you left it, about will robots take my jobs and all these things. Even if for teachers it's not a problem, for many other occupations it's going to be an issue. And there's many people talking about how, like Mackenzie is talking about how 30% of the activities of the major occupations in the US could be automated, how the World Economic Forum reports is talking about how 50% of the companies expect that automation will lead to reaction in their full-time workforce by 2022. And there are many other people talking about the same topic on how this is going to happen. And they all point out that one of the things that is going to be more key for this phenomenon is all the lifelong learning, how people will have to retrain themselves more often than before. So retraining means that universities, colleges, other educational providers will have to be providing the contents not only in the beginning but during the whole life of the work period of time. So however, what happens very often is that in many universities, and this is just one example, in many universities it happens that they provide some virtual online education and so on, but typically only in certain fields. Like if you check many universities, they provide mainly like in business, in languages, in marketing, in those things, but it's usually not so much in engineering. If we go to online courses like in Udemy, Coursera and so on, it's always the case that, for example, for software development, you have like 10,000 courses and probably more. However, for finding engineering, you have to go to teaching academics, and there you will have something of engineering. If you check in engineering, it's only 480 courses, and that includes already software development. In Coursera, for example, you check business and computer science, and then whenever you go to physics, the number of courses drops. It's like so less. If you go to and this is not something related to the future of work that we were talking before. Like all these jobs are jobs that have like a future, even according to those reports. Like we're talking about electronic technology engineers, chemical processing operators, and so on. So, however, whenever you go to any of these platforms, you see that philosophy has more courses than chemistry, music and art more courses than mechanical engineering, history more than electrical engineering, which may be fine, but it's actually surprising. And yeah, Lambda School is yet another, and those like don't even have anything on this. So I wanted to, because like even though this talk is just after lunch, I wanted also to try to ask you things so it's more interactive. So what do you think it happens that there are always many more courses on, like there are always less courses on engineering and physics and this kind of courses compared to other type of like almost everything else in their fields? Does this happen to your universities as well? Do you provide online courses and mainly in like software, marketing, business, languages, never in industrial engineering, electronics engineering, and so on? Okay. So it happens. And why do you think it happens?
Because engineering and other practical courses require physical objects to interact with and physical skills that can't easily be learned online.
Okay. Yeah. So you actually need physical things. We learn software and so on. You can code in your computer. Languages, you can do the exercise in your computer, but everything else is always like typically more difficult in case of physics and so on. Any other reason? Anyone else? Okay, so in like how can we improve it? as you mentioned, one of the key challenges is the experimentation, like being able to experiment with physical objects, as you said, through the internet. So laboratories require a physical location, and whenever you go to online courses, the number of courses and enrollment drastically is lower. But this is also a problem. Experimentation has also other challenges, even in presential classroom, in normal traditional education. For example, it happens a lot with, like even with high schools, but also in universities. You never have as much equipment as you could have, or as you would like to have, because of this problem. Because you have to buy the equipment, have the time for the equipment, have the time for preparing the lessons with the equipment, maintain the equipment, and all these things. So both in traditional and online education, educators need affordable and real experimentation. What in LabsLand, what we are working on is in providing remote laboratories, which are real laboratories available online, where the student can use real equipment from their computer. So I'm going to first introduce it with a couple of examples. In the first case, I'm going to use one of the robots. If I go to here, in this case, I can write my own code. This is mainly for schools. We have another version which is like with real code. And then I can compile it online, which is more normal. And then I can submit the code I just made to one of the existing robots, wherever they are. So right now it will be directed to somewhere, and this is a real robot. In this case, it's in the University of Deusto, so it's in Spain. And I can move this robot and move it wherever I want. And then I can send the code that I just wrote. So I was writing some code. I can see the code running inside the robot. So after a couple of seconds, it will be my code is running here. So whenever I'm pressing the buttons, the robot will move, will say hello eTEE 2019 and so on. If I go back, I could change the code and then send it back to the laboratory. In the same way, let me see. So in that case, like what we have is this kind of robots there, which is what we just saw. So with a set of cameras, you can actually see the particular robot. In other cases, we have electronics laboratories. I'm not going to show this one, but we also have FPGA laboratories. How many of you teach with FPGAs or use FPGAs at all? Like in electronics engineering? Is anyone? No? Okay. Oh, like Janus. So in this case, it's similar. Like if I go to the particular laboratories and I go all the way to for example, the Intel laboratories, I could write code in VHDL or Verilog, and then I will be able to do some code, synthesize it, and submit it to a real FPGA somewhere else. So in this case, I will go to Navarra in Spain, to other university, and I will be able to send my code, and then start click on the buttons, and then in the real world there is one of these boards which is actually executing my code and running my code. So here I can play with these and so on. Now, if I go back, so in this case we have laboratories in University of Federal of Sao Paulo in Brazil, and also in UPNA in Navarra. However, all this field of remote laboratories is a pretty old field. It's the first remote laboratory that we know is in 1993 in Ohio State University. There are many universities that have developed remote laboratories, like from MIT, the Hardison, and Sakrison is in Sweden, Murray is in Australia, and so on. So I don't know how many of you have already used remote laboratories before in class or just by test or something. Anyone has used? Other Janus? So So how many of you have used, do you use it in class or?
Our students sent, let's say, request to the laboratory in Vienna.
Okay.
We did an experiment and gave us the result.
Okay. And do you still use it or?
Not this year.
Not this year. Okay. So typically using it every year, anyone? All right. And why is this? What were the problems in your case, for example, for not using it more years?
It's difficult to say because sometimes the group of students, they are willing to do experiments, even our own lab is very occupied and it's not so easy to arrange it. At the first year there's a problem of language because we like to communicate in English and not to translate the students' work into the laboratory people. Yeah, mostly those two.
Okay. So but I understand, like they sent the things in English and then somebody had to translate it to.
The question is that the students should send the request of the question in English. But at the first year, the language skills are not so developed.
I see.
So it was a problem.
And was there any other problem?
No, it's of course the availability of such lab in Vienna, yeah, the cooperation, because we cooperate with the Technical University of Vienna. Sometimes they are limited, the opportunities are limited.
Yeah. Dennis?
The mentality of my management is from the 19th century.
Yeah, that's always easy. And any other problem with this? Okay. So typically there are several problems, including like robustness of the laboratories. Sometimes laboratories are broken because typically, so far in the literature, always is like one university has one laboratory, they provide it kind of like as a friend, like to other university, and they use it, but sometimes the equipment is broken and things like that. Sometimes it's not scalable in the sense that you need many boards or many, because if you want to use it in class with many students, it's a problem. Sometimes the development is complex, like typically you need many different people, like you need software people, you need hardware people, you need pedagogic people, and many research teams don't have all of them. You also need certain critical mass of laboratories, because sometimes if you want to convince the management for using this kind of solution and you only have one laboratory, it's more difficult than when you can actually provide something better. The iterations in the university context, like all the GDPR, all these kind of issues with the privacy and so on. And also the sustainability, like making sure that what happens if in Austria they don't maintain equipment in 1 year or something like that. So in LabsLand we were trying to focus on each of these topics. So the first one would be robustness and trust. In our case, like every remote laboratory we provide is always like located in more than one university at the same time, so we can guarantee that if one is broken, at least we have another one that replaces it. So for example, in the case of the electronics laboratory, we have it in University of Georgia, in the TU Dortmund in Germany, in Costa Rica, in Costa Rica, also in Spain, in the University of Deusto. The robot that I was showing, we are building another copy in Colombia, and South Africa, we will deploy it next month. Basically, what we try to do is to have multiple copies so as to avoid that if one is down, which is something normal, we have issues with that. Also, we have like a lot of computer vision and so on to make sure that like every couple of hours we're checking all the robots to see if one is broken and this kind of thing. Regarding scalability, I'm going to show one quick demo of other two laboratories. For example, if I go to the inclined plane, to kinematics. In this case, the student can select an angle like 32 or whatever, and they can start the experiment. And they can see a red ball and a tube, and the tube is moving to reach the 31 degrees. Whenever it reaches those degrees, the ball drops, and there are a set of sensors which are measuring in what millisecond the ball drops. So at some point it's going to drop the ball, and when this is done, each of these blue things are sensors that have measuring what millisecond was 56 centimeters. Like it took 527 milliseconds to go. In this case, going back to scalability, the issue is how to have like many of these if you want to use it in class with other students. However, in many cases, in many laboratories, like in this one, the student can only select one value from 1 to 90. So what we did in this case was we recorded like 90 times, like each of the angles. We recorded it several times, so we have 900 recordings right here. And whenever the student selects, what we saw is not real time. It's not happening in Brazil anymore. What happened is that we selected an angle, and then we are loading the particular video and data of randomly one of those 10 recordings to get that value and show it to the student. This way, like all data and multimedia are real and pre-recorded. In this sense, we also have laboratories of radioactivity that in Australia, which has more than 6,000 recordings. Like it took like more than 3 weeks to record all the potential combinations of the student. In the case of University of St. Thomas in Houston, we have laboratories of biology where you put a worm in some water with caffeine and you compare how fast it moves compared to putting it in regular water and so on. Regarding the development process, we have provided many, like as University of Deusto and LabsLand, we have provided many open source technologies for development of remote laboratories because we are interested in universities being able to create their own remote laboratories in a scalable way. And we also have the service of developing remote laboratories with universities. We typically work with universities for creating those laboratories. It's not only that we don't have like all the laboratories in our office or something. We partner with universities and provide them access to developing these laboratories. And what we are working on is creating this large network of remote laboratories, including like that's a flow loop in Germany, in Clausthal, where for petroleum, for drilling engineering. Like in India, we have laboratories of electronics, FPGAs with ceilings, pendulum, and right now we're working with 21 universities in 11 countries in all the continents. We have like from Australia to India to Germany, South Africa, everywhere. And with them we create all these laboratories, or we install laboratories there, and so on. Regarding integrations, like we also are supporting like all the major learning management systems like Moodle, Sakai, Canvas, Alias, Blackboard, and Google Classroom, especially for schools. And the students don't, so this way the teachers don't have to actually have all the, like the students don't have to register in LabsLand.com or anything like that. They just go to the learning management system and automatically access the particular laboratory that the teacher wants. And the instructor can know exactly who accessed what laboratory in what moment and so on. So there is this unified platform for that. And regarding sustainability, we are actually, like LabsLand is a spin-off of a university. What we are charging to consumers to access the laboratories, and then we are compensating the providers. So for the providers have some incentive to maintain these laboratories and so on. We are focusing in universities and schools, all in between traditional universities, but also distance universities like UNED in Costa Rica, also high schools. And yeah, LabsLand, as I said, we are a spin-off of a university in Spain, in Bilbao. The co-founders are actually my colleague Luis and myself. The main office is in Bilbao, near the university, while I'm located in the San Francisco Bay Area in California. And yeah, if you want to check all what I was presenting today is available in LabsLand.com, and if you go to the funds and so on, you can actually use it for free and so on. And if you send us an email, like you can use it for several months for research or testing or whatever. So yeah, with this I finished my presentation.